Everybody, let's take a look at question 14.74. And so this is a question that's more of a theoretical question and probably isn't going to require any math. Okay, but the question starts off saying confirm that the elementary reactions add up together. We're not going to look at that. Okay, we're going to avoid that question. But it says based on the experimentally determined rate law, which is the rate determining step. So from the rate law that you're given here, and this is what you have to be careful of, okay, is that the rate law can be given to you, but it doesn't have to be given to you in equation form. And so we have rate law equals K times the concentration of HBr to the first times O2 to the first, because it says it's first order with respect to HBr and first order with respect to O2. Okay, so this is our rate law. Now, notice that the rate law doesn't reflect the stoichiometry of the reaction, of the overall reaction. The rate law has an order of 1 for HBr, not 4, and has an order of 1 for O2. It just is coincidental that the coefficient of O2 is 1. Okay, where this comes into play is for part B, when we have to determine which step is the slow step, or sometimes we call that the RDS, the rate determining step. Okay, and so the rate determining step reflects the stoichiometry, or the stoichiometry of the rate determining step is reflected in the rate law. Okay, so we have 1 HBr and 1 O2. Which reaction has a coefficient of 1 for HBr and a coefficient of 1 for O2? Well, it's this reaction right here. So that first reaction is what we call the rate determining step, or sometimes we would call it the slow step. Okay, and it says what are the intermediates in this reaction, or in this mechanism? Well, intermediates by definition are those things that are made that are then consumed in another part of the mechanism. And so if we look, this compound HOOBr is made in the first step, but then it is consumed here. And here HOBr is made and it is consumed here. Okay, so it is very, so these are our two, let me highlight them. So this and this are our two intermediates in the mechanism. They are the compounds that are made, but then subsequently they are used up. Okay, and so therefore we're not going to see them as a product. And that answers question part D here. It says if you're unable to detect HOBr or HOOBr among the products, does this disprove your mechanism? No, not at all, because you make them and then they're consumed in the next step of the mechanism. So that's kind of the stepwise through a mechanism. Keep in mind that a mechanism has to add up, all the steps have to add up to the overall reaction. You have to make sure that the stoichiometry of the slow step reflects the rate law, which it does. And, and for this problem, that's all we have to figure out. Okay, so I hope that helps you clear up some mechanism problems.